Okay, guys, we're going to do our intro to stoichiometry. We have a question here that says a reaction where 0.500 moles of lead 2 chloride reacts with 0.500 moles of potassium iodide. Okay, so the question then is going to be which reactant will run out first or will be consumed first. Now, looking at the question, the way it's written, right, it's hard to tell because we have the same amount, right? We have 0.500 moles of potassium iodide and 0.500 moles of lead chloride. So for this is why we need stoichiometry, okay? All right, so let's take a look here. First thing we got to do is we got to write a balanced chemical equation, right? So write balanced chem equation. Okay, so I'm going to translate lead 2 chloride into a compound. Now, if this looks familiar, it should, because this is the reaction that we did for an example of our reaction types. And then the other one is potassium iodide. Okay, all right, so based on this, I can see that this is going to be, let me see if I can get a different color here. This is going to be AB plus CD. So I can already see that this is going to be a double replacement. So when I have a double replacement reaction, the metals just switch places. So I'm going to rebond lead with iodine, which is going to give me a lead iodine 2 plus potassium chloride. Okay. How did I do that? Well, I know that lead in this case, because of this number here, is a 2 plus. And iodine is a 1 minus. So when I form the compound, these charges cross over and I get my compound lead 2 iodide. Okay, remember, subscripts do not carry over. You need to make sure that you rebond them on the product side over here. Okay, because if the subscripts carried over, then there would be no need to ever balance. Okay, so now let's balance the equation, right? Let's see. Okay, so I'm going to go through here. I see that we have 2 iodine, so I'm going to add a 2 here. Okay, that changes this to a 2. All right, and that should be it. So if I was to balance this equation, this would be lead chloride plus 2 moles of potassium iodide produces 1 mole of lead 2 iodide and 2 moles of potassium chloride. Okay, so now that we have this, right, we have a balanced chemical equation. Now we can find the mole ratio, right? So here are the 2 elements that I'm working with. The first one is lead 2 chloride, and the other one is potassium iodide. Okay, so that's going to be this guy right here, lead 2 chloride, and this guy right here, potassium iodide. Okay, I know that I have 0.500 moles of this guy, and I have 0.500 moles of this guy, right? So what we need to do, the question is asking which one of these 2 is going to be consumed first. So being consumed first means which one is going to run out. Remember that a chemical reaction will only carry forward if you have reactants. If one of those chemical reactants runs out, then the reaction stops, right? So what we're going to do now is we're going to identify the mole ratio. So we've already seen mole ratio. We know that it's super, super easy. So because we're working with lead 2 chloride and potassium iodide, I'm going to take the mole ratio of lead chloride to potassium iodide. Okay, so that's going to give me a ratio of 1 to 2. Another way to write this is that for every 1 mole of lead 2 chloride, I have or need 2 moles of potassium iodide. This is how I want you to write from now on, right? Ratio from now on, okay? You can find it using this method here, but I need you to write it like this because this is also going to serve as a conversion factor, okay? And guys, that's basically all stoichiometry is using a balanced chemical equation to convert from one compound to another in terms of quantities or moles or atoms, using the mole ratio as a conversion, okay? All right, So let's take a look. Okay, we have our conversion factor. This is our mole ratio. All right. So what I'm going to do is I'm going to use the amount given. Okay. At this point, you can pick either one of these. You can pick either the potassium iodide or the lead 2 chloride. I'm going to start with the lead 2 chloride. So that's going to be 0.500 moles of lead 2 chloride. I'm going to put that over 1. Okay. Then I'm going to multiply by the conversion factor. The conversion factor in this case is the mole ratio. Now I have the mole ratio right here. Okay, this is what it looks like. Do I plug it in exactly the way it is, or do I need to flip it because of what I'm starting with, right? Remember that whatever unit I have here is the same unit I have to have here. So because of that, I'm going to go ahead and flip this ratio over. So it's going to say 1 mole of lead 2 chloride, right, times 2 moles of potassium iodide. Okay. All right. So when we do this, right, we're doing just a conversion, and look what happens to moles of lead 2 chloride. See, they cancel out. Just the same way we've been done all the other conversions, you're going to do exactly the same method when it comes to stoichiometry. This is why I've been stressing you guys to write down the process. Okay, so now I'm going to multiply everything straight across the top, everything straight across the bottom. So that's going to be 0.500 times 2 moles of potassium iodide over 1 times 1, which gives me 1 mole of potassium iodide divided by 1, which gives me 1 mole of potassium iodide. Okay, so this amount here, right, this is your calculated amount. This tells me how much potassium iodide I need. Whoops. This is the need. Okay. So I need 1 mole of potassium iodide. So I need 1 mole of potassium iodide. Okay. Now, when we're talking about need and have, right? When you have a reaction, depending on how much of the reactants you have, for example, the lead 2 chloride, this is how much I have. For this amount of lead 2 chloride, I would need 1 mole of potassium iodide. This is how much I need, okay, for the reaction to run to completion. Now, going back to the question, okay, I'm going to highlight this here. This is the amounts that I actually have. So I have 0.5 moles of lead 2 chloride, and I have 0.5 moles of potassium iodide. So in this case, I have 0.5 moles of potassium iodide. So the question is, based on what I need and what I have, you ask yourself, do I have enough potassium iodide? Right? Which number is bigger in this case, 1 mole or 0.5? Well, in this case, the one that's bigger is the need. So that number is bigger. So because since I need more than what I have, do I have enough potassium iodide? And the answer is no, I do not have enough, because it's telling me right here that I need 1 mole, right? But I only have, right, 0.5. I only have 0.5. So based on what I'm seeing here, I do not have enough, okay? If you do not have enough of one of the reactants, then we call that potassium iodide the limiting reactant. Limiting reactant. Okay. If that one is a limiting reactant, then the lead 2 chloride is therefore the excess. That means that's the one I have too much of. Okay, now let's take a look at this real quick, okay? The last time we did this, all right, we started with lead 2 chloride right here. So now we're going to start with potassium iodide. It's going to be exactly the same thing, okay? But now we're going to start with potassium 2 iodide or potassium iodide. So you can see that no matter which one you pick, you always get the same answer, okay? So I'm going to multiply now by the mole ratio. Okay, so this is 2 moles. Let me see here. Whoop. Yes. 2 moles of potassium iodide to 1 mole of lead 2 chloride. Okay, in this case, the moles of potassium iodide cancel out. Okay, multiply everything straight across the top, multiply everything straight across the bottom, and you end up with 0.5 moles of lead 2 chloride divided by 2. If you multiply or divide that out, then you end up with 0.250 moles of lead chloride. Okay. So again, using the mole ratio, this is just the mole ratio as your conversion factor, you're able to convert from moles of one compound to moles of another. Then we ask ourselves the same question, right? Okay, so this calculation tells me that I need 0.250 moles of lead chloride. From the question, I know that I have 0.500 moles of lead 2 chloride. Okay, so which value is bigger, the need or the have? In this case, I have more than I need, right? So do I have enough? And the answer is yes. I have more than enough. So because I have more than enough, more than I need, the bell rang early, then lead chloride is my excess. And if this guy is my excess, then potassium iodide is equal to the limiting, okay? So by using stoichiometry and using the mole ratio, I'm able to determine which one of these guys is going to run out first. And the answer is the potassium iodide is consumed first. All right, thanks guys.